Welcome to today's webinar on the latest updates to the California Title 24 Residential Energy Code. It is not uncommon for Title 24 to be updated in mid-code cycle. Usually the state is either fixing mistakes or adding new energy-saving technologies to the code mix. This update's a little different. While variable capacity heat pumps have been around for many years, Title 24 used to punish their usage. Pretty much out of nowhere and pretty much without telling anyone, the CEC, the people who write the Title 24 Energy Code, is now greatly encouraging their use. We will go over some of the reasons for the switch, as well as just how significant the credit is, and hopefully everything else California architects need to know about this efficient all-electric heating and cooling option. We will also show many examples of how variable capacity heat pumps, VCHPs, can be pleasingly incorporated into homes and how these are likely to be a big part of the future of true zero net energy projects. The last part of the presentation will show how best to achieve true zero net energy projects using variable capacity heat pumps. My name is David Knight and I work for a small, humble mechanical engineering company called the Monterey Energy Group. We offer full MEP design, highly focused Title 24 consulting, and solar electric design. We work more or less full-time for around 250 of California's very best architects, and last year we consulted on just around 1,200 projects. Since 2007, we've been promoting and implementing true zero net energy projects. While we are licensed in 3 other states besides California, most of our work is in the Golden State, and our main office is in Carmel. Joining me today is Jose Adela Portilla from Samsung. Jose is the National Training Manager for Samsung HVAC. Jose has been in the HVAC industry for 26 years and has worked in service, installation, technical support, and training, which is his passion. Jose serves as a member of the NATE Technical Committee and is an ACA Certified Residential System Designer. Jose received the NATE Golden Toolbox Award and the Silver Stevie Award for Education Leadership or Education Leader of the Year in 2017. Jose focuses on educating the HVAC industry in many ways and extremely passionate about the HVAC industry. Sorry, one more item. If you'd like to receive our full presentation notes, as well as several other related handouts, please email Monterey Energy Group's office manager, Jessica at M.E.G, and she will send you a link to all that information. Okay, let's get going. Title 24 qualified VCHP units can be ductless or ducted as long as the total duct length is no more than 10 feet. These systems are affordable, reliable, easy to zone, and can provide simultaneous heating and cooling, and they're quiet and very space efficient. Most importantly, besides the great Title 24 credit, they use electricity very efficiently, so they are perfect for your all-electric projects. The trick, at least for custom homes, is to make the VCHPs look great. This webinar will give architects the tools to be able to plan for the limited space required. The images shown here are a great example. By slightly thickening the partition wall over here, the space in the lower right is conditioned without being seen. I mean, you see the low supply and the high return the low return high supply register. The required service panel is hidden behind the artwork. Both systems will work great, whether you can see it or not. The trick with this unit here in the lower right is again, to qualify for the VCHP credit, the total duct length needs to be 10 feet or less, and that gets used up really quickly. And you can see here, that's pretty much right at that's probably like 8 or 9 feet of ducting. So it qualifies for the credit and will beautifully heat and cool the space. One of the inherent advantages of variable capacity heat pumps is zoning, and Jose will go over this in his presentation as well. Recent events, and I would argue long-term trends, really underscore the value of zoning. The homes architects are designing are no longer just homes. They have become offices, classrooms, gyms, and spas. They are also increasingly becoming rental property through ADUs or junior ADUs or vacation rental by owner. Zoning and simultaneous heating and cooling used to be an extravagance. Now with the VCHPs, zoning is pretty much built in without much, if any, additional cost. Most of you know that Title 24 means having to meet an overall energy efficiency budget, and that budget changes based on the size of the home and the climate zone you're building in. I've always described Title 24 as miles per gallon for your house. You can build the house any way you like, as long as you can prove you're getting 250 miles per gallon or more. Title 24 keeps getting harder, more miles per gallon. And while the enforcement keeps getting ramped up with either building officials, HERS inspectors, Cal Green inspectors, or Build It Green inspectors, the enforcement is more serious than ever. Residential Title 24, as you know, looks hard at the building envelope, but sharp energy consultants understand the real compliance keys lie in HVAC, domestic hot water, and solar. It was just a few years ago, Title 24 made going all electric a very big challenge. Now, you will see it's just the opposite. The big picture on climate zones is, for the most part, if you hug the coast, complying with the code is hard, but not impossible. The Central Valley is incredibly hard, and the desert's even harder. Climate Zone 16, which is the mountains, kind of surprisingly easy, and it's been that way for a long time. Okay, here's a sample house. This is a nice 3,400 square foot house in Los Altos, which is in the middle of Climate Zone 4. Some of you may know Los Altos is one of the 70 or so cities, and growing, that no longer allow natural gas or propane to be used for space heating or domestic hot water. You can get a complete list of these REACH codes in our Dropbox handout that Jessica can send you. Again, just email Jessica at M.E.G. Here's the result page from the Title 24. As you can see, the house has R30 in the ceiling, 21 in the walls, 19 in the floor, and it's all electric because in this case, the code doesn't allow, the local code, the REACH code does not allow anything else. The U value of the glass is 0.35, and the house only has 32% glass to floor area. Yeah, 20% is the prescriptive maximum, but almost no one ever meets that. The heating and cooling in the sample house is a high efficiency heat pump with all the ducts in conditioned space. Due to the duct lengths being over 10 feet, it's not VCHP compliant. As you can see, the house, the result page is we're minus 15.4 below the standard. If you're below the standard, you don't get to build the house. With this run, I keep everything exactly the same. I just switched to ductless VCHP units, and now the house complies. Doesn't comply by a mile, but we went from minus 15 to plus 0.5. The value here, besides gaining compliance, is we didn't have to change the building envelope at all, or add batteries or an optional HERS inspection like HERS QII. Either of the last two options would have added at least $10,000 to the project, whereas the VCHP heat pump more likely reduced the cost of our HVAC system. I'm sure you're thinking everyone knows Climate Zone 4 is pretty easy, and the sample house only had 32% glass. Fair enough. How about this nice glass box in Climate Zone 14, the hottest and hardest climate zone in the state? And this house has 60% glass to floor area. This 1,800 square foot house with a 60% glass, which is 3 times the state's prescriptive maximum, and the metal frame doors and windows have a U value of 0.38, which is, 0.3 is again the prescriptive maximum. This house doesn't comply, we're minus 6.2, and trust me, we tried everything we could think of to try to get it into compliance. R53 in the roof, high wall insulation, batteries, HERS QII, and a new solar electric to domestic hot water system, which is one of our very best energy code compliance tricks. No luck, we're minus 6.2, we don't get to build the house. Again, this project, 60% glass in the hardest climate zone in the state, and just by switching to variable capacity units, the house now complies by a healthy 12%. We went from minus 6 to plus 12%, 18% straight up, and we probably reduced the overall HVAC cost as well. It's really quite an amazing compliance credit. Here's a fun aside. Not only do the VCHP units help comply glass homes in the desert, these round units fit well into that overall look they were going for with a kind of a semi-round design. Besides custom homes, remodels, additions, ADUs, variable capacity heat pumps are a great value for multifamily projects. To remind everyone, any multifamily project that is 3 stories or less is considered low-rise residential in the energy code, and therefore it's basically the same energy code as new single-family dwellings. Our third case study our case study project is a 10-unit multifamily project in Sacramento. Sacramento is in climate zone 12, and it's a brutal climate zone. The standard run assumes a 92% efficient furnace, 16 SEER gas AC, or 16 SEER gas air conditioning unit, right? And all the ducts in conditioned space. And even with high levels of insulation and only 13% glass to floor area and an efficient gas tankless water heater, the project is still minus 5.1%. So we're not in compliance. All I did here is change the HVAC from the 92% efficient furnace and the 16 SEER to VCHP ductless units. We went from minus 5.1 to plus 15.8, 20% straight up. Let me mention again, 3 months ago or so, the results would have been just the opposite. I could be wrong, but I believe your clients who are developing multifamily projects will be thrilled with this heating and cooling option and the fantastic Title 24 compliance credit it comes with. Basically, what's going on here, big picture, is the CEC is signaling that all electric is the future of California. And one of the first ways they're doing it is by giving this great compliance credit for variable capacity heat pumps. Okay, so that is the first portion of the training. For the middle portion, we'll be sending it now to, again, Jose Della Portilla, Samsung's HVAC National Training Manual.
All right, thank you so much, David. If you could just hit that stop sharing button up at the top, I'll grab a control. Here we go. And I just want to say thank you to everyone for joining us today. And I want to thank David. That was a really great, interesting, deep dive into code compliance and how variable capacity heat pumps can be that solution that you are looking for. So what I'm going to focus on today is a little bit about the heat pump industry. We'll talk about comfort, zoning, simultaneous heating and cooling. Talk a little bit about the space requirements, because these units are so amazing. They can be positioned in just about any place possible. And I'm going to show you that flexibility. We're going to talk about the power requirements because they are so much lower than traditional unitary products. We'll focus a little around on IAQ and how we can address some of those indoor air quality strategies. We'll look at some control options that are available. We'll compare the sound and how amazingly quiet these systems are. And we'll talk about average warranties you'll see throughout the industry as well. What I do want to say is why we're doing this presentation today. If you have questions, you have things that you'd like answered, please don't hesitate. Just put them in the chat box and ask right away. And I will do my best to make sure that I'm monitoring every single chat that comes in so we can answer them live time. If we miss any, don't worry. The great team here is going to be able to back us up and tell us what things we need to revisit. So without any further ado, let's start looking at the history of heat pump systems. Now, many people think that they are new. They're really not. They've been in the industry, as you see in the upper left-hand corner. They've been in the industry from 1914 is when the first residential heat pump was launched. First residential AC was launched. From there, it was just up to 1946 when heat pumps started to be installed in residential applications. And heat pump technology really bloomed in the 70s as we were focusing on that energy crisis that came up. So what I want to highlight here is if you look at Samsung, and this is how we're positioned, if you look at our formation of our HVAC division, on the lower left-hand corner, you'll see that bluish triangle-shaped box. We started our division in 1974. By 1984, we had created our first heat pump. And then moving up 2 images to the right, you'll see in 1999, we launched our first AC inverter-driven system. Now, that was great. It gave us that ability to ramp up and down, variable capacity to match the load, but we could do better. And what we did is in 2004, we launched our first DC inverter-driven system, which gave us a lot more benefits in saving energy and becoming more compliant. And as the standards have changed, we've just kept updating and updating and updating, which is very typical for most manufacturers playing in the VCHP category, the variable heat pump capacity. So what I do want to show you here is this is not new by any sense of the means. If you look in the lower right-hand corner of the screen, you'll see that variable capacity heat pumps have been on the market for 22 years. And each year, they just keep getting better as technology improves. So let's talk about the difference between a traditional heat pump and a variable capacity heat pump. On the right, you're going to see an image of 2 cars driving. And I want you to focus on the image on the right with the gray car going up the gray hill. This is much like a standard car driving on hills with just a foot on the accelerator. You really have to lay into that accelerator to climb, to climb, to climb, to get to the peak. And then once you get to the peak, you got to drop off the decelerator or the accelerator, which causes the car to drop rapidly in speed. Now, if our target zone is that blue rectangle across the middle, is where we're the most energy efficient for driving a car, you can see that a standard automobile is all over the place, shooting really high, wasting fuel, shooting way low, wasting fuel, and it just creates wear and tear as well as efficiency problems. Now, the car on the blue hill, you'll see the green car riding on the blue track. I want you to compare this to a heat pump system that has variable capacity. It's constantly modulating. It's doing everything it can to match the heat load in the structure. And unlike a unitary product, which is on or off, one or two stages, this capacity can rate anywhere from full capacity. For example, if we're talking a 3-ton unit, 3 tons capacity, it can ramp itself all the way down to as low as 4% of its total capacity, which is just something you can't do with standard products. Also, when this thing needs to recover from a setback, you're seeing here on the screen that car can go up and down and modulate to keep that temperature comfortable. But when it's coming back from setback, unlike a traditional system where the motor can only operate at 60 hertz of frequency, as a motor is driven in the US as alternating current is, because we're using DC inverter driven technology, when we need to recover from a setback, we can ramp up to 130, 140 hertz to get cooling just that fast, or heating just that fast. What I want you to focus on now is that middle range. That is our target, our comfortable range, as you see in that blue rectangle. And because that car has a cruise control, or because that compressor is variable capacity, it ramps up, gets to where it needs to go, and just floats all day long to make sure we maintain comfort and efficiency throughout the entire day. Now, this longer runtime that it produces is going to make sure that we have one, really, really great temperature control because we don't let the air become stagnant and heat up. But two, if you're in an area struggling with humidity, it controls humidity precisely because the first thing any HVAC system has to do is remove the humidity. Only after the humidity is in control can the individual's comfort or sensible cooling be felt. So let's talk a little bit about comfort, zoning, simultaneous heating and cooling. For some of you, this is old news. You know this, okay? For some of you, it might be new. So I'm going to present it from a very entry-level explanation. And should you have more questions, please, just like I said, let me know. When we take a look at comfort, zoning, simultaneous heating and cooling, the first thing we have to tell you is just because this is a variable capacity product doesn't mean you throw manual J out the window. Everything still needs to be designed to operate according to those manual J designs. So as you're looking on the image on the upper right here, you'll see that we have a city. We have Huntsville, Alabama. The AP simply means we're designing for the airport weather station. And if you take a look, the heating 99% dry bulb is 20 degrees. And what that means is we'll only be below 20 degrees 1% of the year. That's according to ACA manual J. When we look at the cooling 1% dry bulb, the summer design temperature is 92. And according to ACA, will only exceed that 1% of the year. Now, I know in the state of California, there's tons of microclimates that you have to adjust for, but this is just a rule of thumb that we'll see. So when you have a unitary solution, a single stage or two-stage solution, obviously because we're only at or above or below design conditions 1% of the year, the system is almost always grossly oversized, which means it turns on, turns off, increases wear and tear, consumes more energy because that starting lock rotor amperage, when it pulls that lock rotor amperage, is a lot of current to deal with. It kind of leads to those dimming lights that you see in homes and a lot of wear and tear and a lot of energy consumption. That's not the case with variable capacity heat pumps. What I want you to focus now on is the chart in the lower right-hand corner. It says performance on the big square box closer towards the left. And across the top, it says nominal capacity. And this unit in cooling on that top line there says it can produce 36,000 BTUs of cooling. Heating, it can produce 40,000 BTUs of heating because of that extra heated compression. That compressor generates more heat. Now, when we look at the capacity range, this is what I really want you to focus on. Right underneath the 36,000/40,000, we drop down and you can see that our cooling range is actually 41,000 BTUs. So while the unit's rated at 36, because of that ramping up of the frequency above 60 hertz, we can get 41,000 BTUs out of it. Here's the great part. Look at the term down. when we are less than design conditions outside and the load inside the structure is being maintained, whether because of the construction techniques or just the load compared to outside, that unit, instead of being 36,000 BTUs, can turn down all the way down to 14,000 BTUs. It's amazing. This is showing you how it adjusts with the load. Look at heating, it only gets better. When we look at heating, we have the ability with that 3-ton unit to produce 4 tons of heating and then stage down or turn down all the way down to 11,005. Okay, this is where the best bang for the buck is with variable capacity heat pumps. Now, another thing to keep in mind, as David mentioned, we're either doing no ductwork or very little ductwork. Now, ductwork plays hell on a load calculation, especially when we have ductwork. And let's say we do it and we follow the guidelines and we get it down to 6 and 6% leakage. We still have to account for the air that's being lost and the unconditioned air that's being drawn into the system. Because really, if we look at it, there's very few places we can actually install these in the conditioned space. So because of that, you have to add extra capacity to your load calculation. And then just the fact that the ductwork is placed in an unconditioned area leads to heat loss and gain, depending on what mode of operation you're in, that we also have to account for. Now, this is not the gospel according to Jose. This is according to ACA. ACA states that that combination of duct leakage and duct loss and gain can equate to anywhere between a 1/4 ton to a full 1 ton of capacity. So being able to put this unit in the conditioned space in the forms of cassettes and high wall units, you eliminate duct leakage and you eliminate duct loss and gain. Being able to utilize the small ducted units with, as David mentioned, around 10 feet of ductwork, you really minimize that. And that really takes a great play in our load calculation as we can remove some of those factors that make us oversize equipment. So this next animation, I just want to compare systems. So in this image here, we're looking at a traditional single zone heat pump. We've got an air handler in the unconditioned space and a condensing unit outside. When that day first starts, you see that the sun's hitting only one area because the sun's rising up in the east and it's hitting that one side of the house. Now the thermostat is on the right side of the house. And because of that, we have heat being built up in the left side of the house, but the thermostat doesn't see it. So the occupants are uncomfortable and the air conditioner doesn't know any better. Then as we migrate to the midpoint of day and that sun's at noon high, we get heat in the structure. And finally, that thermostat says, you know what? You're right, let's turn on. And it's all or nothing. So you see the blue area comes up and we condition the entire structure. Fine. But now let's move to sunset. When that sun crests over and we're on the western side of the structure, take a look at the heat load. Now, of course, this is just us talking. This is not engineered out and I don't have the load calculation to show it, but it's just a design of the homes. We have the heat gain built up on the right-hand side of the structure. Now we have the inverse of what we first saw. The thermostat's seeing the heat and it's saying, all right, we're on. But because it's all or nothing, and on the left-hand side of the screen, we don't have heat load affecting that building, we have people who are uncomfortable because they're cool. And this is where single zone systems struggle. So the next solution that came up in the industry is we migrated over to a single zone variable capacity heat pump technology. And what these were used for was spot treatment, right? If you notice here, when that sun first comes up on the left-hand side, that mini split doesn't care. That variable capacity heat pump just doesn't care because it's not in its zone. As the sun crests over here into the noonday, that variable capacity heat pump finally sees it because it has its own controller in the space and says, you know what? It's time for me to ramp up and start providing some cooling. Okay? And of course, this is cooling mode. It'll do the same thing in heating, just in the inverse relationship. Now, when the sun finally crests over to the western side of this house and we have some heat load here and it's really baking that room with heat load, look at the rectangle, the blue rectangle here, or the blue square. That system just simply says, all right, ramp up. Let's meet the needs of the zone we're in. So this gave us a lot of flexibility for human comfort in the space. But because we're utilizing a single zone mini split variable capacity heat pump unit with an existing unitary system, it's not that efficient because we're only conditioning a zone, not the entire structure. So let's take a look more at a more whole home approach. For example, we have a 36,000 BTU system. We have an outdoor unit that's rated at 36,000 BTUs. But as you look at our combination of the 4 indoor units, we actually have 44,000 BTUs of indoor unit capacity. Now you may be thinking, wait a minute, if every zone comes on at the same time and I have 44,000 BTUs of calling from the indoor units and only 36,000 BTUs outdoor, we're going to have a problem. It won't satisfy. And you're absolutely right. But let's go back and look at the structure and see how often every zone is calling. Okay, we're going to utilize that diversity in the structure to our advantage, and it gives us many benefits. First thing we're going to look at, if we look at the left-hand side of the structure when that sun rises, we have 3 zones that are being affected by that heat gain right now. And so we have those 3 zones come on, right? So we have, a couple wall mounts or whatever units they are, ducted units, they're all running at capacity. And so right at this situation, we have a 12,000 BTU load in one zone, a 7 and a 7 in the other. So on this side of the day or this time of the day, we only really need 26,000 BTUs of capacity. And since this is a variable capacity system, and we saw that it could go from 3 tons all the way down to 14, we don't have a problem meeting a 26,000 BTU load. We can do that all day long. When we get to noonday, that load shifts and our diversity starts to kick in. Notice the rooms down at the bottom, they just don't need as much, or the room up at the top doesn't need as much cooling. So it throttles down, and that 4-way cassette in the other zone comes in. So now we're looking at 4 units running. We've got 1 unit saying I only need 12,000. The next one saying, you know what, I'm working pretty hard here. I need 14. And then those final 2 units are saying, we only need 3 and 3. So our combined capacity at this point for demand is only 32,000 BTUs. Still not a problem. And finally, when that sun gets over to the western side and we're at full load capacity on that western side of the building, take a look at what happens. The unit up in the top left says, all right, I don't need hardly anything. The one in the lower left says, you know what, I'm just going to turn off. I'm happy. The one in the center there, that 4-way cassette that's occupying most of the space, kicks up, it ramps up. And then that unit down on the bottom, middle area says, you know what, I don't need as much capacity. So what does that do to our load profile, where we're looking at 6,000 BTUs in the upper left, we're looking at 18,000 in the right, and down below we have 5 and 0. We're only looking at 29,000 BTUs. That's why we can get away with what we call a higher than normal connected capacity ratio. We effectively, if you look at the lower left image of the screen, we effectively have 22% more capacity of indoor than we do outdoor. And that's fine. We can manage that. Any multi-zone variable speed capacity heat pump can manage that and adjust to the structure. Take into consideration that from multi-zone systems, you can step up into what we call a multi-zone heat recovery. And what multi-zone heat recovery does for us is it gives us, let me just get an annotation tool here real quick. Okay, here we go. We put 1 unit outside, just 1 unit, mind you. We put the 1 unit outside, and then we pipe 3 different refrigerant pipes to these boxes inside the house. We call these a mode control unit. And what they do is they route the right volume, quantity, and condition of refrigerant to meet the load in the structure. This is called heat recovery because we are going to recover heat from someplace that we don't want it and reject it to someplace that we do. So off of this first mode control unit, you can see we have a ducted unit here that's in cooling and it's absorbing heat. And we have a room over here perhaps that needs heating. So instead of relying on the energy from the outdoor unit, we're simply using that outdoor unit as a pump to push refrigerant through. It's maybe running at a lower volume and velocity. So we take the heat that we absorbed from here and dump it over here. Simply just rejecting that heat using the waste heat. Over here, we have another unit in cooling. Over here, we have another unit in heating. And you see that we pipe through our first mode control unit to a second. And from that second mode control unit, we have 1, 2, 3 in cooling. And then we have a 4th one that's in heating. So that is what heat recovery can do for you. All right, let me get back to normal control here. And now, since we've talked about heat recovery, we've talked about the energy efficiency of these things and how they meet the load, let's talk a little bit about the space requirements, because that's a big one, especially in California, where you have specific requirements on where these things can be placed and how much space they can take up. And in some areas, you're looking at very smaller lot lines between one structure to another. You have to have the proper spacing and clearance. I know when I lived in California, we were running into situations where we were using unitary equipment, but having to run buried refrigerant lines through the backyard to the back corner of the house so that sound level from that unit didn't interfere with the neighbors in any way. Well, with mini splits, variable capacity heat pump systems, you have a much more forgiving installation. First and foremost, these units here, as you see in the images on the left side of the screen, They're only about 13 units deep for most manufacturers. That might vary a little bit depending on size or brand, but they're only about 13 units deep. The fan is not on top, it's on the side. And as such, if we look at this image in the top left-hand corner, you see it says when the air outlet is opposite the wall, we can bump that unit right up and only need about 12 inches of clearance between the wall and the back of that variable capacity heat pump. And then it absorbs heat, draws air in from the left and pushes it out the front. If we're flipping that around the other way where the fan needs to blow against the structure, well, that's fine. You just need about 60 inches to put that away from the wall for air circulation. The next image on the top right, you can see that we put it in kind of an alcove, and we just give you some minimal requirements. You need 6 inches on each side, and then you need about 12 inches in the back. So extremely flexible, really easy. The one thing that you can't do, you can't completely enclose these. You can't shove them under a house because they still need to breathe. They need air to circulate. Here's just a few images. And of course, these are going to vary and you may or may not want to put these here, but I just want to show the flexibility. In the upper left-hand corner, you can see one of these variable capacity heat pumps. Again, it's only 13 inches deep. It's back off the wall about 12 inches. And as you'll see in a little bit, that sound level is probably around 58 to 60 decibels at the most. We see people put these outside of windows, glass doors, because they're just not objectionable. The sound is not a nuisance. Okay, if we look down at the lower left-hand corner, this is maybe a bigger structure. It has two variable capacity heat pumps. They're side by side. And what I like about this image is they're spaced out pretty far. They could even be put closer together to prevent them from taking up too much space. Now let's migrate over to the upper right-hand corner. Here you see a variable capacity heat pump sitting outside on a little balcony on a apartment complex or a hotel complex this happens to be in Hawaii, but we see this all over the place. These things can be mounted and placed just about anywhere to meet your building requirements. And down, finally, looking at the center image, you can see that this space happened to have it was a multifamily dwelling, and there were 3 different units all connected near each other to minimize the amount of floor space they took up. And again, because they're so silent, people hardly even notice when they're running. So great flexibility for installing them in the space. When we look at the indoor units, again, they really need minimal amount of spacing. This image on the right here is a ducted unit that you see can be mounted about 13/16 of an inch below the ceiling, right up against the ceiling. And then you need that same 13/16 of an inch below the unit to the access panel or the closed lid ceiling. We do recommend access panels just for serviceability, but that's just another feature. And if we look down in the image on the lower left-hand corner, this is what we call a 4-way cassette. And you can see the same thing. They can be mounted right up to the ceiling. The ceiling tiles can go right around it. And then you simply need, clearance underneath it to avoid obstructions and air recirculation. They need to be serviced, and you do need to make sure you have space. And that space that you're going to need is going to vary based on the size of the unit you pick on your manual J, and then the physical footprint of the unit as well. But what's really unique is these systems are very small in size because they're treating zones, not the entire structure. And they're using brushless DC fan motors that can ramp up and down and give you a lot of flexibility based on your installation needs. So let's take a look at a couple images of these being installed in the space. So in the upper left-hand corner, you can see those high walls. And I know that that's not the unit that everybody's most popular with, but they do have some great benefits. They have very long throws, very quiet. And because they're in the living space, they recirculate the airflow very quickly. The upper right-hand corner, you can see that this is one of those small ducted units. It sits right there in that soffit above that bookshelf, and it probably has about 3.5 feet of ductwork, next to nothing. Coming down in the dead center, you can see what they did here was put multiple ducted units in a soffit, and then they have the returns on the backside. Again, very minimal amount of ductwork, but because they're right in a soffit, the discharge of those variable capacity heat pump indoor units is blowing right out the diffusers, and it gets into the space quickly with a good throw. Now down on the lower right, you can see another way of doing the variable capacity ducted units. They've just got small ducted systems with slot diffusers. And so you can't even notice they're there. And when these things run, the sound level is extremely low, which we'll show you in just a couple slides. So they're amazing at how well they perform and are not noticed. I mean, if we talk about comfort, remember, comfort is the only thing defined in its absence. If we've done our jobs right, people will not see the air conditioner. They will not feel the air conditioner. They will not smell the air conditioner. It'll be silently blended into the background. The only time they'll know they have an air conditioner is when it doesn't work, which when I get to the warranty sections, you'll see why that's not an issue either. Now, in the lower left-hand corner, you will see a window with a vent underneath it. And what we have there is a console style unit that's built into the wall. And on the very bottom, there's louvers that you can't see near the black border on the bottom. And then it diffuses the air out the top. That's a very popular design. We're seeing that a lot in the East Coast, where they used to have boilers or radiators, but it's migrating into new custom homes more and more each year. So we talked about these being extremely efficient, using very little energy. And let's take a look now at what the power requirements are for these systems. So here you have what we refer to as our one-to-ones, meaning you have one indoor unit and one outdoor unit. And that's illustrated by that image on the top left of the white area. And then down below, we have what we call our multi-zone units. And that's where you might have 5 indoor units connected to one outdoor unit. Both of these are very common to use and they're very energy efficient. But let's take a look at it. If you take a look at the outdoor unit on that blue box on the left-hand side, we're going to run a 230-volt circuit to the outdoor unit. And depending on the capacity, that breaker will need to be somewhere between 20 to 40 amps maximum. Now, if we're looking at some unitary condensers, that might be 60 amps just to start with. The difference is if you look at that image on the left-hand area of the white picture, what you will see is that on one-to-ones and multi-zone systems, the indoor unit gets its power from the outdoor unit. That means there's one less breaker. The indoor unit or the outdoor unit sends power typically through a 14-gauge wire that has 3 conductors. So you have your L1, your neutral, and your ground. And that outdoor unit powers the indoor unit because they have next to no power consumption on those brushless DC fan motors inside these units. And then they need to talk to each other because it's a completely digital system and every single component is communicating with each other 24 hours, 7 days a week. The communication on most of them is ran with a separate cable. We use a shielded cable that runs between the indoor unit and the outdoor unit. It's typically a 16-2 shielded cable, and they're ran in a daisy chain. So when you look at that unit down below, you can see they can be chained together for easy installation. One of the reasons we do run shielded cable on these is because we do have a lot of stray frequencies within a house, whether it's other high voltage lines crossing near the ductless unit or the variable capacity unit, or you have large Wi-Fi signals. You can get an induced current to go towards that cable. But because it's shielded, it prevents those induced currents from entering into the communication wires, and it bleeds them off to ground. Now, as we look at those single-phase VRF, which is the multi-zone units that have the ability to heat and cool at the exact same time, they're just a little bit different. On those, the outdoor unit receives that 240-volt circuit that's going to range between 20 to 40 amps, again, depending on the capacity. But if you notice here in this image, the indoor units are all typically wired together off of one breaker. So in this example, we have 4 indoor units being fed power from a single 15-amp 240-volt circuit. They can all be connected together. They typically just need their own shutoff switch near the indoor unit for serviceability, but they're there. So you've got just a really small breaker for all those indoor units. And then again, the communication is going to be that separate 16-2 wire. And for most manufacturers, they're looking at like a stranded shielded cable to help bleed off any interference or prevent any nuisance communication errors with the system. So typically when we talk about variable capacity heat pumps, people look at them and they think about those mini splits and they think, well, there's really not a lot of indoor air quality functionality. Well, there is. We have to approach it a little bit differently. You know, really what most people like to do is they like to decouple the ventilation system from the cooling system. So maybe they'll use like a small energy recovery ventilator or a heat recovery ventilator to purge the old air out, bring fresh air in, also act as a filter media for air particles going through the structure. But indoor air quality technology has improved so much on these variable capacity heat pumps that we can do a lot more than they used to do 20 years ago. For example, on these wall mount units, there's a filter typically located up on top. Put your hands on the left and the right, that whole filter assembly snaps right out. It can be washed in the sink, vacuumed off with a shop vac or a standard vacuum. And what you'll notice is that the capacity or the micron size of the filter is greatly reduced as well. The openings on those filters now can be as low as 390 microns, which is really going to help capture the contaminants that are floating through the structure. And they're electrostatic, so the negatively charged filter wants to grab those partically charged dust particles and hold on to them so they don't go back into the space. As you look at cassettes, this is an example of a 4-way cassette. And we also have them what they call a mini 4-way cassette. You have those mini 4-way cassettes or those cassettes that can actually have a factory installed option for a MERV 13 filter. And that MERV 13 filter can snap in. You might change a setting on the thermostat. It increases the fan speed to compensate for that increased duct or increased static pressure. Now I see Craig had a question here. How often do the air filters need to be cleaned? Of course, Craig, I can't give a one number answer. I have to put a disclaimer out there first. It depends on the lifestyle and it depends on the conditions in that space. In other words, if somebody's got 5 Labradors, you're going to change that filter, clean that filter every couple of weeks. But if they have a ventilation system that keeps the air particles clean, keeps this air circulating, and those particles can stick to the ERV, typically we recommend a monthly basis to pull those filters down and wash them. And the nice thing with variable capacity heat pumps, when it comes to wall mount units and cassettes, those filters are electrostatic. They can be washed and put back into the system. So it's really easy for a homeowner to comply. Now, when we look at ducted units, like I'm going to show you here, the ducted units, you can take a filter box or a filter grill like you normally see in a structure and attach it to the back of the ducted unit. On those, you wouldn't necessarily wash those because washable filters that fit into a filter box or return air grill are typically very restrictive and have a higher pressure drop, which affects the total volume of air you can get out. But those we would recommend being changed monthly or more frequent depending on the quality or the conditions in the living space. So I hope that answered the question, Craig. If not, throw something else at us and we'll keep on going. Okay. My goal here today is to answer every question that I possibly can so you walk away with the best amount of knowledge. So again, ducted units here, put that filter box on, duct lengths 10 feet or less. This is the nice thing that David brought to my attention. I didn't know is that on duct lengths of less than 10 feet, you don't need to comply with that MERV 13 filtration requirement. You can get away with a lower MERV rating filter. You do have to size the ductwork accordingly based on a ACA Manual D. And that's going to take into consideration the pressure drop of the coil, the pressure drop of the filter, the total effective length of any fittings, and then the linear length to calculate how much air is actually going to flow through that duct system. Okay, so whatever filter you put in, if it's designed, you can sometimes overcome a lot of that. Now, MERV 13s can be hard because they are very restrictive. But again, with this setup and less than 10 feet of duct, you don't necessarily have to worry about that. Okay. All right, now let's take a look at some of the control options. As you look at control options, there's lots of different options out there, and they vary, and you can utilize all kinds of things. Now, if you look at those one-to-ones or those multi-zones, a very common controller is a wireless controller. Looks like like a remote control on your TV, has a little bracket that can be mounted to the wall to slide into. Some people don't like those because with those, they have a propensity to being lost or misplaced. So if you look over, we have a touchscreen controller. Most manufacturers have the same thing, a touchscreen controller that can be put on the wall and interface, which is, normal touches of the button. Next to it, there's an advanced one that has like a dual set point. So you can add a heating set point, a cooling set point, run some additional features to it. The nice feature about most of the variable capacity heat pump controllers is that if you put the controller in the space, but you also give someone a wireless controller, they can point that wireless controller at that wired thermostat, push a button, and it'll read the infrared signal. Beautiful situation for bedrooms. You have the thermostat mounted on one side of the bedroom, put the wireless controller on the nightstand. And in the night, if they need to change something, they don't even have to get out of bed. Added human comfort for the individuals. Now, some people definitely do not like electronic controls. They like to use their thermostat they're familiar with, or they like their connected thermostat that they use with their existing platform. Fine. Most manufacturers have a thermostat adapter that can mount on the wall, can interact with a standard 24-volt thermostat, and still allow the system to ramp up and down in capacity all day long, even though that thermostat is just really giving it a start and stop signal. Okay. As we move down to the center line there, it's what we call our central controls. Now, central controls are just that. If you've got multiple variable capacity systems in the home, you can mount this touchscreen controller on the wall. It's probably about 4 inches in diameter. Put it on the wall. You've got a touchscreen, and you can monitor and control every single variable capacity heat pump from one central location. So you can see it, you can monitor it, turn it on and off, change the settings, fans, whatever, and you've got all of that flexibility and comfort that you want. For other individuals, there's Wi-Fi adapters, which we'll talk about in just a second, that can mate up to an app and give you full home control. I love this, and I'll show you the features in a minute. Now, if you have a home that's integrating with a custom home automation system, we have what we call BMS, Building Management Systems Integration Platforms, that'll take our systems and convert them to BACnet, LAN, Modbus, and you can interact with these gateways to make that system work with any control system that can possibly be designed. Now, when you look at the ability to use Wi-Fi, many of these modules now come with built-in Wi-Fi modules. Some of them may not come with a built-in Wi-Fi module, but you can utilize that Wi-Fi adapter. Now, I can't speak to everybody's brand. Everybody has their own platform, but I am going to speak to Samsung's platform here. We utilize a software called SmartThings. It's made by Samsung. And with SmartThings, you can integrate your air conditioning system, but you can also integrate any other Samsung smart appliances, washers, TVs, dishwashers, robot vacuums, you name it. And those devices typically have a voice control action to them, which in Samsung world is called Bixby. And so you could literally look at your watch and say, hey, Bixby, change my air conditioner. Hey, Bixby, what's the temperature in the house? Hey, Bixby, turn on my vacuum. You have that ability to control the system anywhere that Bixby is available. Other cool thing about SmartThings and in other platforms, I'm sure there's other ones out there that are similar, but you can create a whole simple home automation platform. If you buy any devices that are made by SmartThings, such as light switches, locks, doorknobs, motion detection sensors, cameras, they automatically integrate with the SmartThings platform, and you can build custom home automations. Also, if you happen to have anything that's connected, either Wi-Fi, LAN, Z-Wave, or Zigbee, they interact with SmartThings. Also, if you have a home automation or a voice control system in your home, a Google Home or that other one from Amazon that I'm not going to say her name because she's going to start yelling at me when I say it. If I have those two in the structure, then I can interact with them to control the variable capacity heat pump systems. And these type of apps are only getting smaller, or smarter, I should say, not smaller, smarter. They use temperature settings, operational mode. You can on and off schedule with them, but you can do things like create scenes and automations used on, based on very simple if this, then that statements. If I am within this many feet of my home, then turn on the air conditioner. And if it's 8 o'clock at night, turn on the washing machine. All self-automated, it does everything it needs to do by itself. Down in the lower right-hand corner of the screen, you can see that these apps that you can utilize from the manufacturers of these equipment also uses geofencing. So the example here would be if all the connected devices, the phones, tablets, whatever, are in the structure, the system knows everybody's home. Let's run to those set points. The minute those devices leave, it knows people aren't home and it goes and sets itself back. Then with geofencing, it looks at how far away you are from the structure and the rate of speed that you're traveling to decide when to set things back to the conditions you want. So the minute the end user walks in the door, they're comfortable. I mean, this is just the technology we're just scraping the surface of right now. Okay, a few more things here, and then I'm going to turn the time back over to David, but let's talk about a sound comparison real quick. So let's take a look. If you look at our ductless units, so our ducted variable capacity units that we've talked about, you see these ductless units right here run at about 19 dBA. Because they run at 19 dBA, that's about the volume of a whisper. Look at the ducted versions. They're at about 23 dBA. Again, about the volume of a whisper in the space. You never know they're running. What about the outdoor units? I said you could put them right up to windows and things like that. Well, look at this. The residential unit is going to come in around 45 dBA. And these commercial ones are going to come in somewhere around 50 to 58 dBA. We're talking a library or a quiet suburb. Now, these PTAC windows, the units that you would see in office spaces or hotels. Sorry, let me go back up here. Okay, here we go. Okay, these PTAC units here are coming in at about 50 to 60 dBA, which is around an office conversation. A higher efficiency residential 310 unit is going to come in between 65, right around 65 dBA, but a standards builder model is going to come in at about 75, sometimes closer to 80. And now we're comparing them to the sound volumes that we'll see with chillers, dishwashers. They become much noisier. So the products that you're looking at with variable capacity, not only do they meet the needs to help you get energy compliant, provide perfect comfort within the structure, they're also noise compliant with those noise standards. Now, as we look at warranty, you can see that the warranties are amazing. You can't get these warranties out of the box with other products. Standard warranties typically range around 7 years with 1 to 5 years on parts. And then they offer extended warranties for 10 full years on the compressors and 10 full years on the parts. Now, the contractor typically provides that labor warranty for 1 to 3 years, depending on where they're at. But what you're looking at is warranties that stand the test of time. Manufacturers wouldn't offer these kind of warranties if they thought we were going to have failures and keep bleeding parts out. So they stand behind their warranties. Now, if you take a look at the average lifespan of a system, you know, ACA typically says that lifespan somewhere around 15 years. These systems can go way beyond 15 years if they're properly maintained. All right, that's about all I have. I answered a couple questions that came in through the chat box. So we'll leave this open to any questions that you might have. But at this point, I am going to turn the time back over to David to pick up our remainder of our presentation. But I am here should any more questions come in. It's all yours, David.
Okay, thanks, Jose. That was great. All right. Let's see. Okay, I'd like to think that given all the Title 24 compliance credit and the inherent performance features just described, you're becoming at least interested in using variable capacity units. The next step is to properly size the PV system to match the usage of your specific project. Your clients are expecting a zero net energy home. Let's give them one. It's not only the right thing to do, it is also the most long-term economically, the most economically beneficial option. A couple other thoughts that have kind of occurred to me in the last hour is, you know, the state by this new code compliance credit for VCHP heat pumps is really, really encouraging you to look at going all electric. 70 cities have outlawed new gas or propane hookups. And we've got the AA 2030 challenge trying to do the same thing. The trick for architects is proper PV sizing. You know, going all electric is a good logical decision, but we really have to be careful on the proper PV sizing. Okay, so let's go back to our sample house. As you recall, this 3,400 square foot house is all electric. The state solar mandate only require a 3.5 kilowatt system. If that sounds small to you, it is. Title 24 solar mandate only looks at lights, which are all LEDs, standard appliances, which are mostly Energy Star, and plug-in loads, which are almost always insignificant. The state still assumes, oh, Michael, come back. Where did I mess up? Oh, you know what? It might be down here. Oh, shit. There. Sorry, I hope that's better. I think Michael just in our office just, oh wait, I didn't share that.
There we go, David. We can see your screen now.
Oh, sorry, everyone. I went off on a major tangent in the wrong direction. So, okay, let me start that again. Oh, you can hear me. Okay, well, so you can hear me. Just the screens weren't psyched up. Okay. Anyway, so on our sample house, again, only a 3.5 kilowatt system is what the state mandated. And if that sounds small, it really is. And again, the state only looks at just a few things in terms of how they size solar: lights, appliances, plug-in loads. They don't look at anything else. And that's a trap for architects. Per the CEC minimum, our sample house would only need 9 410 watt panels. Well, the good news is you would only need to locate, an architect would only need to locate 180 square feet of panels. The problem is your client's electric bill, even with a 3.5 kilowatt system installed, at today's rates in Northern California, your client's bill would be around $600 per month. Your client is expecting zero electric bill, and they get, at today's rate, again, they're going to be cutting $600 checks to PG&E, and that's at today's rate, and it's very likely to go up. Here's how we properly size PV systems. The Title 24 software does a fine job of calculating the standard non-HVAC, non-domestic hot water usages inside the home. From there, through our questionnaires and spreadsheets, we can account for pretty much anything else attached to the project's electric meter. This client, as you can see, wants a small wine refrigerator, an extra freezer, an extra refrigerator, and a home control server with a dedicated AC unit. And we're just getting started. This is a 2 Tesla family driving each car going 15,000 miles a year and a 10-person plug-in spa and a little bit of outdoor lighting. That adds up to a lot of usage. Here we're basically accounting for that usage. Based on our energy model, the predicted annual kilowatt hours per year would be right at about a little over 28,000 kilowatt hours per year. If our solar electric system, the 3.5 kilowatt system, is going to produce about 5,000, that leaves about 23,000 kilowatt hours a year that you're buying from PG&E at about 30 cents a kilowatt hour, which is going to add up to about $7,000 a year, a little under $600 per month, and a very angry client. Luckily, this architect knew the owner's goals of being true zero net energy and also the value of solar, so he gave us a lot of south-facing roof. Here's the layout we ended up with, and besides some monthly service fees, which are really quite minor, this should zero out their bill on an annual basis. True zero net energy for their home, and also all their transportation. We can typically prove that solar provided electricity is the least expensive source of energy Californians can buy. For example, this house, we end up installing a 19 kilowatt solar electric system. The cost to the owner after the tax credits was about $52,000. If we add that $52,000 to a 30-year mortgage at 4%, the owner has to pay an extra $3,043 a year, or about $250 a month. Remember, the projected first month electric bill without any solar was going to be around $700 a month. This system will produce a little over 29,000 kilowatt hours, and when you divide that by the annual increase in your mortgage, you get a solar provided electric rate right at 10 cents per kilowatt hour, solar provided electric rate. And again, the first month PG&E rate is going to average closer to 30 cents a kilowatt hour. So the very first month, by appropriately sizing the solar electric system to achieve true zero net energy, you're reducing their operating costs by 1/3. But also, the story even gets a little bit better, because as you know, your mortgage payments, to at least to a certain degree, are tax deductible, where your residential electric bill is not. And for most Californians to pay PG&E 30 cents, you have to make 50 cents. So the real difference between solar and the grid is more like a 5-to-1 savings. And don't forget, we've now fixed your client's operating costs for the next 25 years, the life of the system. Architects have other choices besides your basic black panels. Bifacial panels work great as trellises. They put out a little bit less energy and they cost a bit more, but they look great in the right setting. And since the trellis becomes the solar racking system, it now comes with a 26% federal tax credit. The thin film panels are designed to fit between the seams of a standing seam metal roof. Again, the system will cost a touch more and take up a little bit more space, but the appearance is fantastic. You're probably wondering if ductless hydronic systems like radiant floor heating or radiant ceilings or warm and chilled water fan convectors that use air-to-water heat pumps qualify for the variable capacity heat pumps compliance credit. Even though these systems are ductless and the air-to-water heat pumps do modulate, right now the T-24 results are not even close. We go back to our sample house, and if you recall, with the VCHP unit, we were plus 0.5. If we switch to a hydronic option with using fan convectors, we go down to minus 19. It's a little better if it's radiant, but the results really aren't very fair. And the rumor is the CEC, I think hopefully early this spring, will be updating the software to treat the hydronic option a little bit better. To us, at any rate, variable capacity heat pumps keep looking better and better. Efficient, affordable, room-by-room control, and very space efficient. This low static unit is beautifully built into a 10-inch thick metal casework. You've got a low supply and a high return. And again, you need to have access panels. But the good news is no HERS duct leakage inspections, and you're exempt from the MERV 13 as long as you keep to 10 feet or less of ducting. And of course, that's the key to getting compliance credit. More and more, we are seeing units that are built into high wall, that are hidden behind cabinets and high walls. To remind, the slats have to be removable and they need to be angled towards proper airflow and given a certain distance away from the unit. But you can see you have a lot of options with this type of, with these types of designs. Okay, last topic. As many of you know, there are 4 mandatory energy-related designs required for permit or final for any California residential project. We refer to this as the energy bundle. Title 24, heating cooling system design to ACA manual JD&S, ventilation system design to ASHRAE 62.2, and of course, solar electric design per the state solar mandate, and more to provide domestic hot water. These systems are interconnected and if done right, will produce a healthy, comfortable, affordable, and sustainable project. HVAC, domestic hot water, and solar are also by far the most cost-effective Title 24 compliance option, and none of these will change the way you get to design and build your project. We believe with effective space planning in the home, and especially on the roof, meeting true zero net energy and the AA's 2030 challenge can be achieved without breaking your client's budget. The first of the energy bundles, Title 24. If you do not pass, you don't get to build a house. Simple as that. We believe it is up to the architect to determine the building envelope, glass orientation, glass performance, overhangs, as well as what building system you choose and therefore what insulation levels we are working with. Smart, simple, affordable HVAC and domestic hot water systems really make your choice of the building envelope your choice, and we can comply by adjusting the mechanical. The second energy bundle item is heating and cooling, meaning ACA manual JD&S. This is not only sound practice, it's been the state code since 2010. Jose mentioned how critical properly determining the room-by-room loads are to heat pump system design. That's called ACA manual J. And that's the only way you can design heating and cooling systems is with very precise room-by-room heating and cooling loads. Manual D is proper duct sizing so that the system is balanced and runs quietly. Manual S is the indoor and outdoor unit sizing. More often than not, proper sizing leads to smaller systems that cost less, take up less space, are more efficient, and require less maintenance. Further, ACA manual JDS design produces an HVAC bid set, and of course, better permit drawings. And let's not sleep on that full 15 to 20% Title 24 compliance that I've already shown earlier in the presentation. The third part of the energy bundle is ventilation system design, meaning ASHRAE 62.2. Again, this has been mandatory in California for several years. These systems, known as energy or heat recovery ventilators, provide fresh, filtered, pre-conditioned air into your living space. The best ventilation systems are separate from the heating cooling system. These systems are simple to integrate into your project and are fairly low cost, and if designed properly, come with great Title 24 credit. That's all well and good, but the real value is to helping ensure proper indoor air quality. Many of your clients have allergies or asthma or just flat out just plain neurotic. Architects who do not address indoor air quality are potentially setting themselves up for future liability claims. There's an easy and affordable fix, and again, it comes with a solid 10% compliance credit. The fourth part of the energy bundle is solar. And as you know, a small amount of solar is mandatory. What you may not be aware of is that adding more PV capacity, no matter how cost effective, does not benefit your Title 24 energy budget. To say the least, this has been extremely frustrating, but at least for now, it's the code. The good news, there is now excellent Title 24 credit given to batteries and a new PV to domestic hot water system called SETS, Solar Electric Thermal Storage. Depending on the size of the house and the climate zone, you can expect a 20 to 30% plus compliance credit. Energy storage, given California's flaky grid, is pretty much a very easy sell to most of your clients. All right, that's pretty much it. Thanks so much for attending today's webinar. This is the 5th energy-related webinar we have produced for California architects. These can be viewed on the Monterey Energy Group website under What's New. I will be adding to this library on more or less a monthly basis. Look for new webinars on completely off-grid projects and solar objects for multifamily projects coming this spring. All right, any questions for Jose or myself?
Hey, David, can you hear me? I know
Yes.
Okay,
Yep.
great. So looks like we got the questions answered in the Q&A section. I saw one more question in the chat about radiant floor, which I think you addressed. That question came in before your radiant floor section. Sally Ann had a question earlier. It's a 3-part question. What is the average attic wall space required for a recessed residential mini split indoor unit? That may have been answered in Jose's, but I'll just throw that back to Jose or David, whichever would be best on that. Oops, Jose is muted.
Yep, give me just 1 second here. So it varies on unit to unit, and it does vary sometimes from capacity. So whether you're looking at a small 7K or a 12K, something of that nature, it'll change. Typically, there is no factory recommendation for boxing it in, as long as you maintain the service clearances on the top, the bottom, and the sides. So on our ducted units, the top clearance from the top of the ducted unit to the ceiling can be as minimal as 13/16 of an inch. From the bottom of the ducted unit to the hard lid ceiling, again, can be 13/16 of an inch. And you need to provide a service access panel if it's going to be completely enclosed in a soffit style application, just so that the technician can get their hands in to the components they need for service. Now, on our most popular mini split ducted unit, that can be accomplished in a couple of different ways. The main components can be accessed from the back of the ducted unit or through the bottom. So what we see from time to time is that these are enclosed in like a soffit style application, very minimal clearance around it, with a service access panel that allow them to get to the sides where the refrigerant piping and power come into the unit, and maybe a service access panel on the bottom that can be opened up big enough to get access to the components should they need to change like a fan motor. Exact requirements are going to vary based on size in each manufacturer. But I can tell you that if you want to know more about these, you can go to our website, which is samsunghvac.com. And on the upper right-hand corner, you'll see a tab that says Tech Docs. They can click on that, and they can go to the installation manuals for any of our ducted units they choose and get the exact requirements based on the capacity of the unit and the style of ducted unit. We happen to have about 2 or 3 different ducted units you could choose from. And of course, those are going to vary based on where the service accessibility is.
Great. But just to confirm, follow up on that question, those access panels will likely be much smaller than the typically code required 22 by 30 inch for a mechanical room?
Yeah, absolutely. They're typically just the size enough to get you your hands in around the equipment, to get to critical components. And then some of them, some people like to design them big enough so that if they have to change a unit, they can. Others make them small enough for service with the with keeping in mind that should they need to do a replacement, there'll be some sealing work that they'll do.
Gotcha. Part 2 of Sally Ann's question, are there, I'm sure this is near and dear to the hearts of all architects, what wall ceiling air register grills are available? Are there alternates to sort of the white plastic ones that we see so regularly?
Now, personally, I've dealt with manufacturers like Hart and Cooley, Amerimetals, a few other ones out there that make just about anything. Whether they're stamped faced, which is a less expensive grill, or they're a curved blade where you can adjust, or they have a curve at the end of them, and you can get them in single way, 2-way, 3-way, 4-way to help the directional airflow. And then some of the manufacturers, and I'm going to refer back to Hart and Cooley because I know them most of all because that's who we used to use, even make wooden registers and diffusers based on custom designs and grain colors, so they can match whatever you're looking for.
So that answers the question. We're not married to a manufacturer's grill. We can go outside and customize it.
Of course, anytime they want to, all they have to do is find the grill that they like. And then, of course, when they do their manual D, their ACA manual D, they're going to have to account for the pressure drop associated with the grill. But if you follow standard ACA manual D procedures, you can really design in a whole bunch of things.
Okay. And the final part of Sally Ann's question was, is there a return air grill required for multi-zone systems?
Okay, I'm sorry. My internet connection kind of broke up, Justin. Could you repeat that question one more time for me?
Is there a return air grill required for multi-zone systems?
Okay, so when we look at multi-zone systems, the first thing we have to consider is that if it's a multi-zone, let's say a 5-zone, you could technically have 4 different styles of indoor units. So in that situation, if you have a wall-mounted unit, there's no filter needed because it has its own filter. If it's a cassette unit, that round or square one that would be recessed into a ceiling, again, those have their own electrostatic air filter. The only ones that would need a filter grill, it would be the ducted units. And again, that's completely up to the design of the building. We don't say you have to use X, Y, or Z return air grill. All we say is it needs to be sized in accordance with ACA Manual D to account for the pressure drop, not only of the grill, but the pressure drop of the filter that will be used with it. And then again, consult out to your grill manufacturers and pick the style that you like best that will meet the airflow performance that we need for the unit.
All right. It looks like we have one more question from Craig Bagley. When exactly did the change in energy credit for VCHP come down from the state?
So what happened there is the state updates the energy code software, and you just get a notice that there's a new update, and you download the new software. But sometimes they'll give you a cryptic note that something changed in the HVAC or something that helpful. And so we just noticed that, and we spend a lot of time when we get an update, searching for any possible new energy code compliance credit. We just happened to notice it. I think it was mid-October was when this latest version came down, maybe November, when the update happened.
All right. Well, that looks like it's wrapped up the questions there. Jose and David, thank you again very much for coming on and sharing your knowledge with us. To the attendees, I apologize for the technical glitches that were going on at the beginning there. That's on us, and we'll get it fixed for the next one. Again, thanks a lot, guys, and we'll see you soon.
Okay, thanks, Justin.
Thank you, everyone. Appreciate it.